I'm gonna keep going. So welcome everybody. Thank you for attending. There'll be a second welcome in my videos, so I'm giving you guys two because I care about you. But today we'll be talking about Revit families. I'm going to share my screen and just get on into it. And just as precautions, just don't come up to the podium because I guess the audio will start getting shared and echoes will start happening. So keep that 6-foot radius if you can. And away we go. We go ahead and optimize. And I think this should be. Is the audio not coming through? No. Okay. How do I do this again? Oh yeah. Now we should be good. All right. Hello, everybody. Welcome to the best presentation of the week. We are here. Thank you for choosing me over Zach. It means a lot to me. Today we will be talking about Revit families. My name is James Watts. I'm working with the pre-construction team, specifically virtual design team. I've been here for a little over a year, and I'm excited to share with you all the knowledge I've gained about family creation and families in Revit. So let's hop right into it. The topics that I'll be discussing today, first we'll go over the types of families in Revit. So essentially there's two main types and then one sort of subtype. So the two main types would be system and component families. And then within component families, you can have things called nested families. And I'll explain what those are further down the line. And then we'll get into an overview of system families, followed by an overview of component families. Then following that, we'll discuss nested families and kind of the difference between all three of those. And then I will go into the specific Walters and Wolf component families that we've made and how they work and some of the parameters. And then lastly, I'm excited to share with you all the progress and, the creation of the new Walters and Wolf adaptive families we've been using for raked units and kind of unusual conditions on projects. So first and foremost, let's discuss the three types of families that there are in Revit. So the first and most basic type of family would be a system family. So system families are elements within Revit that already exist within your project. These types of elements cannot be edited in the family editor, which is used by Walters and Wolf and by others to create, more specific customizable families. System families are pretty generic and they can't be edited to add new parameters or anything like that. And they're already preloaded into your projects and they're created by Revit. And then the second type of family we have are component families. Now these are editable in the family editor, and we'll go through what exactly I mean by the family editor. But these are created by templates. And these templates are either, they're provided by Revit for different types of conditions or types of models or components that you'd like to make for your project.
We're not seeing screen.
And they can also be created from custom templates like we have at Walters and Wolf. And with component families, you have a lot more flexibility and a lot more customization that you can add to them. So you have the ability to add things like parameters. You can add constraints. You can put, you can create pretty much things that would be specific to different kinds of jobs or specific industries. And these are also available from Revit. There's a large library of different component families available, both, within Revit once you download the program and have access to all that. But they're also available online by users who create them and share them openly with, whoever might need them. And then a subsector of component families would be something called nested families. So nested families are pretty much a combination of a bunch of different component families. They share a lot of the common traits of component families, where they're editable in the family editor. They're also created from templates, and they also have the ability to have parameters and constraints added to them. And nested families are used pretty much to create more complex geometry or more complex components that can all kind of rely on each other for the overall, function of that component. And we'll get into these in more detail, but just as a broad overview, if you remember in your mind, there's system families, and then there's component families. And within component families, there are things called nested families. So let's talk system families first. So system families are the most basic form of family that we can have in Revit. They're predefined in your Revit project, which means you don't have to load them in. They're already there once you start a new project in Revit. I'll show you what I mean. You cannot create, copy, modify, or delete these families out of your project, but you can duplicate these families within your project and modify the types to create different types of the same system family. And some examples of this would be things like walls, floors, roofs, and stairs. There's a few more, but those are kind of the ones we're probably most familiar with in our processes. Next, we have component families, and these are created using the various Revit templates available from Revit, and they are created in something called the family editor. And these are unique because you can create, copy, modify, or delete component families within your project. You're able to perform save as functions to these families in order to alter existing components, which makes it, easy if you want to make slight moderations to the same family, but don't necessarily want to go ahead and create the family from scratch. And some of these component families that Revit has available to us are things such as windows, doors, and structural columns. There are quite a few more, but just as some examples. And as mentioned before, some of these component families are a little bit more complex or complicated than your standard. So these would be called nested families, and they're created by combining various component families together into one family. And just like, all component families, you can create, copy, modify, and delete these systems from your project. These are unique because you're able to share family parameters to treat the nested families as standalone items, which means, even if you have a bunch of different component families within one family, you're able to break those out separately for things like schedules. And they're also unique because you're able to link parameters from one to another. So you're able to have the main nested family drive things about the individual components within that family. This will all make a little more sense once we get some examples going. So let's dive right into Revit. So the first thing I want to look at here are system families. So here's some examples. I got a wall here, got some roof, then here we have a floor. And as you can see, when you go to your architectural tab, you can just click on wall. Don't save because we don't need to. And then we have all these system families already available to us. We didn't have to load these into our project. We didn't have to do anything interesting to bring them in. Revit already has them preloaded for us. So you just go ahead, draw your wall. There you go. Just created our first system family in Revit. And these are unique because unlike component families, you don't get this option up here to edit family, which would bring you into the family editor. Instead, what you have to do, let's say you wanted to create, a bunch of different basic walls. We want them to be slightly different from one another. You can use things like here with the instance parameters. You can set different heights. You can set constraints if you like. You can do all sorts of things, and it doesn't carry over to multiple families of the same type. So let me show you what I mean. So anything in this section here is considered an instance parameter. So you can have multiple of the same families within your project, but then you're able to edit one without disturbing the other. So as you can see that this and this are both basic walls, but because we're using instance parameters to adjust them, they're able to adjust independently from one another. But let's say you want to have, you want to duplicate this wall, but you want it to be slightly different. What you can do with system families is you can duplicate the type, call it generic 6-inch 2 or whatever you like. Say okay. So now, unlike loading in a new type of family or doing a save as and adjusting anything, you're able to adjust the type parameters of each of these walls independently from one another. So let's go edit type. So these are all the type parameters here. So this allows you to, if you want to change the structure of this, let's say just change the thickness, maybe 10 inches, say okay, apply. You can see that that wall expanded a bit. So unlike, the instance parameters where you can adjust things independently from one another, if I were to go ahead and switch this to a type 2, it's going to change to have the exact same type parameters as this wall, because the type parameters get carried on through all the types that we have here. So these are pretty much the most basic forms in Revit. They're already provided for you. You don't have to load them in. You don't have to do anything special with them. They're there to create basic geometry and shapes and help you lay out your building. But then once you want to get into more specific details, we have things called component families. Let me just delete out these system families really quick. So here are some examples of component families provided to you by Revit. So all of these guys here had to be loaded into my project. we have a wall here, which is a system family, but that's just to host these component families onto the wall. And I can show you how you can load these in. So if you go to Insert, Load Family, and you go to where we have our program data, Autodesk, Revit 2018, libraries, US Imperial, you get this whole large library of different types of families you can bring into your project. So for example, if you want to bring some furniture, let's say a TV, it's the next one. You click OK. And then under your Families tab, under Furniture, you see you have your flat screen TV all loaded in here. Now this wasn't loaded in before because unlike system families, you have to manually load in your component families. And then within this component family, you can see that you have different types. So just because it has different types doesn't necessarily mean it's a system family. Component families can also have separate types. You can just simply drag it on in, place it, and there you have a TV. Now all these are created using Revit templates. And what's unique about these is that you can actually edit them within the family editor. So unlike before where we didn't have this button here, we can actually go and click Edit Family and get into that actual family here. So this kind of allows you to, set different, this is maybe a bad example, but you can set different thicknesses. Let's just do something drastic. Apply. 10-inch TV. And let's say you wanted to, do a save as for this component. It allows you to. So now I can go to Save As, put it in my Documents folder. It says 10-inch. And now I can load this into my project. I can place it right there. Go to my 3D view. You see I have now two separate component families, each independent from one another. So component families can get, rather complex, like I explained before. The TV, it's really just one element, as well as these columns here, all editable if you'd like to. All, different types that you can assign to them, make them grow, expand, and you get options to load in different types when you load in these types of families. There's a big long list of different dimensions that you can choose from, so you can really pick whatever kind of components might work best for you or whatever you need. But then when you look into something like this window, just check out this family. You can see here that we have multiple families within this component family. So this would be considered a nested family. And all families are essentially reference planes with geometry that have constraints that predict how they'll move and interact with one another. So if we look at the floor plan here, you see a good example of what I'm talking about. So you can see all these reference planes with all these things of geometry locked to them with dimensions that you can alter, that allow you to really, flex and customize all these families into the way that you like them to be. They can get kind of complicated as far as formulas and whatnot, but the main point here is that unlike things like walls or like the ceilings or roofs, you have a lot more control over making custom component families and nested families than you do over system families. Now that I've given you kind of a quick overview, and I hope it's kind of clear the difference between what we have system families, and then component families, and then nested component families. Now I'd like to kind of dive into exactly how Walters and Wolff has been using component families and system families for all of our projects. Okay, now that I've sort of walked through the types of families that can exist within Revit, I'd kind of like to showcase some of the custom families that Walters and Wolff has made for Revit. So what we're looking at here right now is a 3-light G unit, and then we have a 2-fold panel. And these were created by Walters and Wolff using Walters and Wolff templates. And they all have different parameters that allow it to flex, allow it to do different things, extremely customizable and unique to Walters and Wolff. I can show you how we load in these components and how we place them as well. So first thing that we would do is create a wall, say tech wall RO, which is actually a custom system family created and saved into our WW project template. And this system family here, as you can see, has custom takeoff parameters that allow Zach to actually read the wall and recognize it and pick it up for the takeoff program. But anyways, what you would do if you wanted to load in, let's say, a 4-light G unit, you would go to Insert, Load Family. You go to Revit, WW Standard Library. You go to G Units. You go to Units. Let's say a 4-light. Click Open. Load into your project. So now what you can do is you can click on your curtain panel. And since all of our G units are created using a curtain panel template provided by Revit and altered by Walters and Wolff, we can just go ahead and switch out our curtain panel for a 4-light unit. And there we have it. And the panels, they actually work the same way. So you can create a wall, switch it out for one of our custom system panels. Then you can go ahead, load family, go back a few steps to our WW standard library, click on panels. Let's just get a flat panel in there. You click on your curtain panel, and then you're able to switch it out for the flat panel. Now let's take a look at this 4-light real quick and just give some explanation. So, like I mentioned before, nested families are made up of a bunch of component families. So here we have, a bunch of separate component families grouped together. Let's actually dive into this family editor so we can take a closer peek in there. Yeah, so right now, as you can see under the family tree, all of these generic models have been placed into this project. And these mullions here, as you can see, can actually be edited within this family. So you can go to Edit Family. You can check out one of these temporary mullions we're using on the sales side. So this would be considered a component family. And as you can see, it's just one sweep, one shape. So it would not be considered a nested family, but just a plain old component family. And if we look at some of the parameters that are set up for this, we have things like front of profile and back of profile, which are set right here. And these allow us to get the correct miters on the mullions when it comes down to having like corner conditions where different angles and whatnot. So we make sure that we're getting the right cut on the mullion itself. We have a parameter here, mullion offset, set to the back of pocket. That allows us to adjust the mullion either forward or back, depending on where the glass is set, and depending if we have to, make any adjustments to the mullion itself. We have parameters, DLO top, which helps us set where we want the shadow boxes and back pans to go up to. So right now it's set, as you can see, to -2.5. And if we take a measurement from here to here, you can see it's 2.5. So pretty much when we draw or when we make these units, the back pans and shadow boxes are going to be coming up to this point here, this little center point right here, because that's the datum point that we're picking from AutoCAD to load in our mullions. And then Alan's tool is able to read the DLO top and set our back pans and shadow boxes to be -2.5 from this point here, which was set it at the very bottom of the mullion here. And it's the same sort of thing for the glass offset top, where the glass is going to be going to this center point. But thanks to this, the -2, it's actually going to slide down into the pocket where it's supposed to be. And then we have different materials assigned to it, WW aluminum. You can see in the 3D views, we have the miters all set, and those can be turned on and off. These visibility settings here. So if we did like, let's say 2 outside corners, you can see that these voids actually cut, they actually cut our part where we want it to. Then those are also adjustable. So you can do like a 30-degree. So it just changes the angle of that cut. And I don't want to get too much into this, but just kind of explaining what some of these parameters are. And then for Zach's takeoff program, he uses is mullion length to pick up the fact that this is a mullion and that he has to read it like one. And then the mullion length he uses to determine the length within his takeoff program. And then for these guys here, how you edit them is actually rather simple. So you can go click on it, do an edit sweep, click on it again, edit profile, and let's say there's just a giant reveal for whatever reason. You can go ahead and move this 10 inches out, pretty wild. Press accept, that, and then you can go ahead and set your front of profile to match where the front of your profile is on here. So there it is. We have this wacky, weird mullion now. So if I was going to load this into my project, you can see that it's going to get transferred over into this 4-light unit. I'm not going to save any changes because it's not necessary. Overwrite, and you see it updates in here. And it's cool. So once you have a bunch of different components within one family, you're able to like tie those parameters that we have within the individual mullions, like you see here, inside corner left miter, inside corner right miter. You actually tie them to parameters that are within this family. So no longer are you, have to adjust the inside corner left miter through this dialog box. You would actually just change it through the family's overall, parameters here. So we have a bunch of parameters set up. Let me just kind of showcase how they're all tied together or how they're fixed together. So we have reference planes on the left and right. Then we have reference planes at the top of all the horizontals. And you can see here that things like the offset are set to 2, which is actually the parameter that's right here. So you're able to set, take measurements within this family, and then use those measurements or those dimensions to actually set, where you want your families to occur or where you want them tied to, so they're constrained. Maybe this is going a little too in-depth, but I just kind of want to showcase how it works. So you have a bunch of separate families. In this case, all these temporary mullions. And then we have glass infills, and there's back pans and shadow boxes. We'll turn a couple of those on real quick. Shadow box on the second light. Apply. And all of these are tied, like their dimensions, their parameters are all driven by the dimensions that are available within this model here. So all the parameters that you have set in the individual components, when you place them into your model, so I'll show you now, you don't have any ties with anything. So you can set the offset to whatever you want. You can make it go way up there. You can do whatever you want with it, really. You can change the miter and all that. But then once you tie it to the parameters that are unique to this frame, like the inside corner left miter, you'll see that it gets locked. So you don't have to change like every inside corner right miter on each mullion. Instead, you just tie it to like the master parameter within this family here. I'm not going to load into our project because I've been messing it a bit, but it's one example of one of our nested families that we've been producing and making, kind of the way it works. And then here we have a panel. So we can see here when we edit family that this has nothing under its family tree. So this is a component and it's not nested whatsoever. It's legitimately just a extruded shape with different parameters tied to it. So as you can see here, there's different parameters to determine the joints on each side, the lengths of the folds, the panel thicknesses, all of that. And it also has parameters tied to it that determine how it's read by the takeoff program. So as you can see here under data, we have is WW glass panel, which Zach uses to actually pick this up and read it through the takeoff. So I don't want to get too crazy with it, but I just wanted to showcase kind of these component families and the ways that you can place them into your project. And then another thing that you can do, since they are component families, You can go to edit family. And let's say for whatever reason, somebody needed a intermediate vertical here or something of that kind. Um, you can actually do like a file, save as, family, like whatever you have. And then you can go and edit this, put an intermediate, put 2 lights in here, and then load it back into your project. Okay, everybody, so this brings us to our last topic that I'd like to discuss today, which will be adaptive units. So I've been working alongside Katan, Gabriel, Zach, Alan, and Yana's giving me some pointers and some help with this one. But we've been developing these units for out of square conditions. So I'll kind of demonstrate why we need these units in the first place. I'll make a little out of square wall here. So let's say we get a unit that needs to be created with the head right this. So what we were doing right with the G units is we were tabbing into this curtain panel and then switching it out for one of our one light G unit families. But as you can see here, once the actual wall or the curtain panel is raked, it can't make our G units in these conditions. So we did a lot of research and development, and we did a lot of playing around with these, and we came to the conclusion that the best way to go for these conditions would be to use what we call adaptive families. So these adaptive families, they're actually made using a different sort of template than what we're used to making G units out of. They're actually called just adaptive generic models. So I'm going to go ahead and show you how I load those into my project. So I go, I tap into LF, which is my shortcut for load family. Let me just show you how you might be doing it. Load family. I'd switch over to my WW curtain panels. Sorry, WW standard library. I'd go to G units, adaptive, and now I'm going to grab an empty frame. And I'll show you why in a second, but let's just make a 2 light. So I'll grab a 2 light empty frame, and then I'll go ahead, type LF again for load family. And then I go and grab my unit, which like we said is going to be a 2 light. And they all have this dash A at the end just to denote them somewhat differently from the G units. So that's getting loaded in. Awesome. So now to access these families, what we have to do is open up the families tree and then go down to generic models. Then you can see here we have a 2 light A and 2 light empty frame A. So I'm going to show you how I go about placing these. So the first thing that you have to do is, let's say we have an opening like this. I'd go ahead and place my mullions. None of my shortcuts are working, so give me a quick second. So I've placed my cock joints. Let's just make them all 1 inch because it doesn't really matter for demonstration purposes. Put a sill track on there. Perfect. Then I would tab into my curtain panel, switch it out for a W75 unit. So we're actually nesting within the wall. And then I would once again grab my curtain panel. And what we've discovered as an easier way to place these is actually to switch it to what we're calling WW raked panel. And this pops the panel way out here. And I'll show you why this helps in a moment. But then I take my curtain grid and I lay it in here. And the reason why I'm putting this curtain grid in is because this is actually going to be controlling the height of the horizontal. Since they're adaptive, it was rather difficult to get a parameter to work depending on, if the bottom was raked and whatnot. It was kind of hard to determine how to keep that horizontal straight and which, side you'd be dimensioning from to receive the top of horizontal dimension. So instead, what you do is you just can adjust this to whatever your desired height is, and your top of horizontal is going to be coming in at 7 feet. Okay, so now what you do is you grab an empty frame, pull it into your project. You can see the general shape of it and how it wants you to place it using points. So the first point is going to be at your top left, and you're going to be going clockwise. So click there, click there, click there, click there, and then click there. Perfect. And I press escape a few times to get out of it. When you click on it, you can see here what we have is adaptive points. So it's 1 through 6 on this 2 light frame. And that just pretty much tells you which points it wants you to pick in order to host this frame. And now I have my empty in. I'm going to go ahead and switch it out for my adaptive unit that has all the right mullions and the glass and everything else in there like we have with G units. And then I go ahead and grab my WW Rake panels and switch them over to empty. And as you can see here, we have our unit nested within that wall like we want it. And then the adaptives are cool because you can go ahead, you can edit profile, you can move things around. You can see that it'll flex to however you change it to. You can change the angles here if you like. And then, like I mentioned before, in order to just change the top of horizontal, you just grab that curtain grid, and you set something like 10 feet if you want. And it adjusts to how you like it. So the main goal for these families was to create them as similar as we could to the G units. And the main difference is the way we place them. And it might just take some getting used to, but once you have it down, it's actually not bad at all to place, even a bunch of these at one time. Demonstrate right here for everybody. Just grab this. I didn't put the, I'm just not gonna put the cough joints just because time constraints, but normally you do the same process that I did with this left side. But for this, I'm just gonna go nice and quickly. Select all the panels, switch them out for raked units, curtain grid in there for the horizontal. And I go ahead and get my 2 light empties. Sometimes it'll want to snap to the back like you just saw. And when that happens, all you have to do is press tab once and it'll come up to the front face here. I'm going to go ahead and do that. Just run through these really quickly so you can see how easy it can be. Once you just get a little practice under your belt and get used to them. And then you select one, press SA for select all, and then I switch them out for my 2 light adaptive units. Just take a second for all of them to load in. And once they're all loaded in there, again, you select one panel. I do SA for select all, and I go ahead and switch it over to empty. Easy enough. So we're going to go ahead and I can kind of show you how these work similar to the G units. So if you look at the instance parameters on this left side, it's nearly identical to what we have for G units at the moment. So you can do things like mullion offsets, set it at 5 feet, something crazy. All the mullions get pushed back. You can send the glass back 10 feet, something crazy. I'm just trying to demonstrate how these are being made to replicate G units, so you don't have to learn a whole new process for how these function. You just really have to learn the way of loading them in selecting them out of your generic models section, and then applying an empty frame and switching that empty frame out for the frame with all the mullions. And just two improvements that we made were, instead of placing the adaptives like we were on the curtain panel like this, it became really, really hard to select the right points, and Zach's program relies on it all being planar. So let me demonstrate what the old process was like. So we have to zoom in to this front face, zoom out, zoom back in, zoom out, zoom in, make sure you get not that point, get that point. It was very painful. So that's why now we've set our rake units at that offset. Because now when you go to set your frame, you can be way out of here if you want, you can be anywhere. You go ahead and just click your points. Sometimes it'll snack back, but you just gotta press tab once, and there you are. You might also be wondering why we have empty frames. So let me show you that. So let's say we didn't have the empty frame and we went ahead just to try and put the two light adaptive in. If I drag that to my project, you can see it's rather slow. It takes a while for it to buffer. The graphics takes, a painful amount of time. It starts feeling weird when you have to pick the right point. It's just very slow and just not the best way that we found to place these. We found it to be a lot faster if we just put an empty frame in that has the general shape and the adaptive points in the right locations, and then just switching it out for the one that has all the parts and pieces that we need. So if we take a look at one of these units, because it's a component family, rather a nested component family, we can go to Edit Family. And this is the general layout of these units. So if I hide all these mullions really quickly, last, I'm just gonna hide all the little parts and pieces that we have inserted so you can see the general framework of these. So how I created these was I used reference lines and then used the points of those reference lines where they intersect. And I switched the points into what they're called, adaptive points. And then this allows you, or allows the frame to flex with wherever you put these guys. So that's why when you're placing these units, you have to select these points in this order, because it's going to go from 1 on the left side of the head, and that's going to stretch out the head over to 2, and then it's going to start with the jam down to 3, to 4, and so on and so forth. And all of these have the same glass parameters as the G units as well. So before Alan had left, he'd actually adjusted his tool to be able to use set frame parameters on these units as well. And that's been working pretty nicely. And we've done a few tests through the takeoff, and things seem to be working pretty well. And it has all the same data as the regular G units. The only thing that is slightly different about these units is when you set elevations, you actually have to set the elevation within the unit itself. I'd like to kind of talk about maybe the mullions really quickly. We tried to set everything up in the same manner that the G units are, even though the templates look a lot different. The general theory behind everything is the same. So here we have one of our mullions. This is the head. We're calling temp head for the sales team. So when you zoom in here, you can see we have the image, we have the datum point at that location where those adaptive points are, and then we have a general shape that's been created. And all these dimensions, like from this bottom part to this top part, all of these are dimensioned out, and locked. So none of those will change once the mullion offset is set on this unit. So the reason why all these have to be locked is because if you were to set this mullion offset to like 8 before, it would actually just drag some of the lines out and it would distort the shape of the mullion itself. And while this all looks kind of complicated and strange, it's very nice because Alan, before he left, actually created a tool or modified his tool that Esley uses to create families in Revit to actually create not only G-unit families, but adaptive families as well. So I'm going to just demonstrate that really quickly. So if we had a mullion like this, let's say, and this was going to be used in operations for, downstream process, all you have to do is type in RP copy, go to our Revit family library, W75, 222, just find that really quickly, 003 or 033. I'm going to grab that, press open. It just saved all the data that had been assigned to this by Esley using these different layers and lines. And then if I go into my my Revit, I go to WW setup and I click on this mullion maker tool. It's going to ask me to save directory. Say yes. Go to documents. I'm going to do Zoom. Sorry about that. Let me just do that again. I'm just going to stick them in this City of Hope folder I have. I'm going to select folder. It's going to ask me if I want to make adaptive mullions along with G mullions. I'll say yes. It's going to run through the mullion maker tool. I'm going to say remove constraints. This error is going to pop up every time. Alan said just ignore it. It works out fine. I'm going to say okay. Now let's go back to our project. Now we're going to pretend like this is a model being used by operations and they need to actually switch out these mullions for, our temporary sales mullions for the correct dies. You do the same process where you go insert, load family. I would go to my folder that I saved this in. Where the hell is it? JWatts, City of Hope. Okay. This one right here. Press open. And that just loaded into your family or into your project. And now, since this was a SIL condition, I can go ahead and switch it out in my project. And as you can see, it gets switched out no problem. So just kind of, let people be a little less scared of these. I thought I'd give a brief overview. Obviously, there's a lot more to discuss and to learn from these. And then you can also use your set frames parameter. I have SF as a hotkey. Click on my unit, press finish, say OK. Bytes panel parameters have been set. So now you can see, we tap into our glass, all the bytes have been set for this unit as well. So they work as similar to the G units as possible. We're able to switch out the mullions. We're able to create mullions rather easily with the tool that Alan made. And right now we're just working on building out our family library for these units on a case-to-case basis. I can kind of demonstrate some of the things we've been working on. So right now for City of Hope, there's a door unit that is raked. So I've been playing with some ideas of how to get that to work. It's been going actually pretty well. Still need some finalizing and some other people to take a look at it, just to, confirm that it is working as intended. We have a bunch of different types of conditions we can make. This was for a project that ended up not going through, but there's a possibility we need frames such as these little triangular frames. What else do we have? Yeah, just a bunch of different lights too. We have 2 light, 4 light. We're able to do these on segmented or articulated sloped walls, as you can see here. We have corner conditions. Again, another demonstration of a segmented and sloped wall. I had something similar on a project, Haas, and at the time I had no clue how to model this, but now we have some kind of idea of how we can go about doing these in an easy way. And then kind of the next step as well is creating panel families. So Daniel had a project where he needed these crazy, I guess they would just be just bent panels or curved panels. And then there's a big group of them. So we have one big panel back here, we have a soffit panel here, and then we have 2 panels coming together at this front side. And these work the same way, where you can go ahead, drag in your panels from the little side tree. I just create these as WW rakes really quick. Grab these, start placing them how you like. Something like that. But anyways, I just want to showcase you guys the possibilities of these, and kind of our future endeavors and some of the things we'll be working on next with these adaptive families. That concludes